Hey guys, so this video is going to go over the probability summative review. So we're going to go over and work through the problems together. Please make sure that you type out your answers and insert pictures of all of your work to each slide. Also make sure you have it up split screen so that you have my video and your slides on the same screen. Okay, so make sure that you are split screening your already completed summative review with this video. You should have typed out your answers in the blue spaces and then inserted pictures of your work. I will be writing out the answers because I don't have ability to type on this. All right, so the first question says, explain the difference between an independent and dependent event. Okay, an independent event is when the first event, the first event does not affect the outcome of the second event. So first event does not affect the outcome of the second event. So that would be something like spinning a spinner and rolling a dice. When you spin a spinner, that first event does not affect the outcome of what you should get on the dice. Or even if you spin a spinner twice, you spin the spinner the first time, it's not going to affect your spin the second time. So the first event does not affect the outcome of the second event. That is independent. For dependent events, the first event does affect the outcome of the second event. So first event does affect outcome of second event. So that would be, for instance, you selecting a raffle ticket from a jar, and when you select that raffle ticket, you leave it out, you don't put it back, and then you select a second raffle ticket. When you leave that first raffle ticket out, you have now changed the outcomes of what's left inside of that jar. So the first event affected the outcome of the second event. So now let's practice that. All right, so here we're labeling the following events: I for independent or D for dependent, and you are to type your response in the space provided. So for the first situation, spinning a spinner and rolling a dice, that would be independent events because spinning a spinner is not going to affect the outcome that you get on your dice. Flipping a coin twice. The first flip, does that affect my second flip? No. So that is also independent. Eating a Skittle out of a bag, then grabbing a second Skittle. So since you picked the Skittle out of the bag and you ate it, there are now less Skittles in the bag. So that would be dependent. The first event affected the outcome of the second event. So if you selected a green and ate it, there are now less greens. So the chance of you picking a green again is now smaller. So that's dependent. Picking out two short shirts from your drawer at the same time. Remember, when you're picking them out at the same time, we treat those as dependent events because even though you're picking them out at the same time, whatever one of them is, you can't pick the same thing twice, so you have to count them as separate events where you left one out. So those would be dependent events. Picking a king of heart from a deck of cards and putting them back, then picking an ace. Since you're putting it back, you are not affecting the deck, so those would be independent events. Picking a blue marble, keeping it out, then picking a second marble. Since you kept that original marble out, the blue one, then there are now less blues, so it does affect your second event, so that would be dependent. Picking an apple from the fruit bowl, replacing it, then picking a banana. Since you are replacing it, then that would be independent because the first thing that you did will not affect the second. Okay, so this slide says a spinner is divided into 8 sections numbered 1 through 8. You spin the spinner 40 times and the results are below. Let's review really quickly theoretical probability. So I'm going to show you a little example up at the top here. So remember, theoretical probability is what in theory you should get. So let's say that I said, what is the probability of getting a 6 in theory, theoretical? We would put for our numerator the number of favorable outcomes. Well, on that spinner, how many favorable outcomes are there? There's just one. That would be getting a 6. Out of the total number of possible outcomes, we have 8 total possible outcomes, right? So theoretical probability of rolling or spinning a 6 would be 1 out of 8, okay? Now the questions below are asking for experimental probability. So this is very similar to the simulations thing that we did. So they're saying, okay, find the probability of a 6, write the experimental probability as a fraction in simplest form. So when you're doing experimental probability, you're going to look at the table that they give you. There's going to be something filled out that has information of, you know, how many trials there were and how many outcomes there were. You should be looking at some information to be using for your fraction. So for experimental probability, we are going to put the number of favorable outcomes over the total number of outcomes, or the total outcomes. So for this one, the probability of a 6, okay, right here is the number 6, and then the number of times the spinner landed on the 6 was 6, right? So for the number of favorable outcomes, it would be 6, because they landed on it 6 times, out of, there were a total of 40 outcomes. So over 40. So 6 over 40 would be the probability, the experimental probability of spinning a 6. Now the question says to write it as a fraction in simplest form and as a percent. So we can simplify this by dividing both numbers by 2, which would give us 3 over 20. Now the last part says to write it as a percentage, so we need to do 3 divided by 20, and you have your calculators you can divide on. That would give us 15 hundredths, which would be 15%. Okay, now let's look at the probability of an odd number. Let me erase my work. Okay, so the probability of an odd number. Well, let's circle all the odd numbers. We've got 1, 3, 5, and 7. And we need to look at the number of times the spinner landed on that number. So we have landed on 1 4 times, a 3 5 times, a 5 5 times, and a 7 4 times. So remember, with experimental, we're going to put the number of favorable outcomes on top. So that's how many times it landed on those numbers. So we need to add 4, 5, 5, and 4, which would give us 18, over how many times was the spinner spun in total? That was 40 times. So 18 over 40 would be the experimental probability of getting an odd number. Now we just need to simplify, so divide by 2, which would give me 9 over 20. And then we need to write it as a percent. So 9 divided by 20 would give us 45 hundredths, and that would give us 45%. Okay? So just remember, theoretical probability is, in theory, what should happen. So you're going to put the number of favorable outcomes over the total possible outcomes. In experimental probability, you're putting the number of favorable outcomes over the total number of outcomes. So you're looking at what actually happened when they spun the spinner X amount of times. Okay, so for this one, we are going to use the dartboards below to answer the following questions. Write your answer in simplest form. So what I'm going to do, I noticed that all of these dartboards are not evenly split. So that's the first thing that I'm going to do. So if I look at board 1, remember, you're going to look at your smallest piece that you have, which would be the size of A, C, or B, and make all of them that size. So I need to cut up this bigger block A into 3 smaller pieces. So you just can extend that line down, as nicely as you can. Okay, so really board 1 has 6 sections total. Okay, for board 2, my smallest would be like the size of B or C. So I need to split up A into 2 parts. And then for B, I need to cut it in half and then also split each half into smaller parts. And this is not perfect, but at least we can get a number. So board 2 really has 8 total sections. And then for board 3, our smallest piece would be the size of B or A, those little wedges. So for this one, extend down again. This is not going to be perfect, and then I need to cut those in half that. All right, so board 3 really also has 8 total sections. So now let's fill out the theoretical probability for each of these. The first one says you throw a dart at board 1. What is the probability of it landing on B? So we're going to put the number of favorable outcomes over the total number of outcomes, or possible outcomes. So there's only one B on board 1. So that's 1 out of how many total possible outcomes are there? That would be 6. So 1 out of 6, or 1/6, would be the probability that you would land on a B. For number 5, if you throw a dart at board 2, what is the probability of A or B? So we are going to see how many A's or B's we have. So let's look. We have 1, 2, 3, 4, 5, 6, 7 favorable outcomes out of a total of 8 possible outcomes. So 7/8 would be the probability on board 2 that you would get an A or a B. Okay, if you throw a dart at board 3, what is the probability of not a B? So let's look at how many are not B's. We have 1, 2, 3, 4, 5, 6, 7 favorable outcomes out of a total of 8 possible outcomes. So again, 7/8 is the probability that you would get not a B. All right, and lastly, let's look at number 7. If you throw a dart at 2 and then 3, what is the probability of C and then C? So this would be compound probability. You've got 2 events happening here. So we're going to look at the first event and then the second event and multiply them. Okay, so looking at board 2, what's the probability of getting a C? That would be a 1 out of 8. And then board 3, the probability of getting a C would be 1, 2, 3, 4, 5, 6 out of 8. And we're going to multiply them. Now I'm going to cross simplify just to make it easy. So my 6 and my 8 can both be divided by 2. So this would be a 3 and that would be a 4. 1 times 3 is 3. 4 times 8 is 32. And that is simplified all the way. So 3 out of 32 would be the probability of throwing a dart at 2 and then 3 and it being a C and then another C. All right, for this one we've got a bag of Skittles that has 6 green, 4 blue, and 5 red. You choose a Skittle at random and then without replacing it, you choose another. So let's figure out the total number of Skittles in the bag. You would add 6, 4, and 5, which would give me 15 total Skittles in the bag. Okay, so first it says we're getting the probability of green, leaving it out, and then a red. So the chance of getting a green, there are 6 total green out of 15 total Skittles in the bag. Now since we did not replace the Skittle, there is 1 less green in here, which makes our total now 14. So the chance of us getting a red next, there are 5 possible reds in the bag. And then we would multiply these two numbers together. I'm going to cross simplify here, again, just to make my math a little bit easier. So my 5 and 15, I can divide both of those by 5. So 5 divided by 5 is 1, and 15 divided by 5 is 3. And then 6 and 14, I can divide both of those by 2. 6 divided by 2 is 3, and 14 divided by 2 is 7. So now I just need to multiply 3 times 1, which is 3, over 3 times 7, which is 21. Now I can continue to simplify here because 3 over 21, you can divide those both by 3, which would be 1 over 7. So the chance of me getting a green, not replacing it, and then a red is 1/7. All right, you're actually going to watch the second video to finish the study guide.